just like an ellipse, a hyperbola, there's two scenarios for them. One of them, it could look like this. It's like two parabolas. And the other one could be up and down. Or it could be up and down. Now, if it's left to right, notice the graph intersect which axes here? X, that'll be x squared over a squared minus, not a plus, that's the first time minus, y squared over b squared is equal to 1. This one, the graph intersect which axes? The y. So this will be y squared over a squared. So a is not the bigger side here. A is always where you intersect the axes. So it could be the shorter side, but we know the graph intersect right there. That's A. That distance. This distance here is A. So we know what that vertex is. A comma 0. And this vertex here, it's negative A comma 0. This vertex here is 0 comma A. This vertex here is 0 comma negative A. And C, which is the focal point, is going to be on this end, not on the inside, on this end. C is the distance to the focal point, and that is C squared equals A squared plus B squared for both of them. So the problem with them is we know which way they're going to open, but how tight are they going to be? Is it going to be really tight like this? Is it going to be flat like that, more flat? How do we know? Just like the parabola. How do we know how tight that curve is? And that's when we have to use asymptotes here. We have to use transverse axes and talk about them. So let's take an example. We'll go through it and see what will happen. So this is done here. Let's say I want to graph this one. X squared over what? 16 minus y squared over 9 equals to 1. Notice it's a minus, we know it's a hyperbola. The positive one is which one, x or y? When you look at this, who's positive, x or y? X, going to cross the x-axis. So my graph is going to cross the x-axis. A squared equals 16, B squared equals 9. A equals what? Plus or minus 4. B equals plus or minus 3. I'm going to do a scale of 2 here just to make it bigger. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. So I have this my vertex right here. This is negative 4 comma 0. This one is 4 comma 0. AA is plus and minus 3. 1, 2, 3. This is A. 1, 2, 3. And what you want to do now, you want to build a box going through these 4 spots, a rectangular shape. You'll see the significance of that box there. Going through all these 4 points. And now it's going to go through this one. I don't know why I made that a solid one. It's a dotted line. With the help of the whiteout, here we go. It's a dotted line now. Perfect. Why do we make the box there? Because that's going to help me graph it. How? Let me draw a line from this corner to that corner going through the center. And that's your asymptote. And let me draw a line going through this one. So my graph is actually, we know the vertex is going to go through this point, and it's going to approach that line. So that tells me actually how tight or how wide the graph is going to be. That's the significance of the box. You're approaching this line. That's your asymptote. We can find the slope of this line. Remember, the distance from here to here is A, and the distance from here to there is B. Do we know what the slope of this line is? B over A. Do we know what the slope of this line is? Negative B over A. Now, we have few names here to add to the list. Does our book talk about them? Transverse axes and conjugate axes, yep. Yes, this line here is called the conjugate axis. That's this distance from here to there. That's this line from this vertex to that vertex. And this line going up and down from this point to that point, transverse axes. That's what these are called. So the transverse axis twice B, the conjugate axis actually twice A. Now where's my focal point? My focal point is going to be somewhere here. Now how do we figure out what the value of that? Well, we need to calculate C. C squared equals what? A squared plus B squared. A is what here? Or A squared is 16. B squared is what? 9. C squared equals 25. C equals plus or minus 5. So right here, this is going to be 5, 0. And the other focal point, negative 5, 0. Again, if there's like a mirror on this end, and you shine the light at it, all the beams will deflect through that point. That's what that focal point is. Let's do another one like it. Let's say we have y squared over 4 minus x squared over 16 equals to 1. Who's positive, x or y? Y. This is going to be up and down, right? So this is going to be up and down. A squared equals 4. A here is always the positive, not the bigger one. With an ellipse, A was always the bigger. A is always the plus here, the positive. The 4 is the positive, that's the negative. So A equals plus or minus 2. I'll go by a scale of 2 again. 2, 4. So that's my vertex. Vertex 0, 2, and there's 1 down here. Another vertex here. 0, negative 2. B squared equals what? 16. B equals plus or minus 4. Let's find where 4 is. 1, 2, 3, 4. Negative 2, negative 4, negative 1, negative 2, negative 3, negative 4. So let's complete that box. And now let me connect the points. You don't have to use a straight edge, but I like them to look nice. So I'm going to make the box. Here we go, the lines, the asymptotes here. This is the other asymptote. And remember, my graph touches the y-axis. So this is going to be really a flat one. That's what the graph is going to look like. Everyone see that? It's going to level like that. Again, to find the focal point, c squared equals a squared plus b squared. C squared equals 4 plus 16, which is 20. C equals plus or minus the square root 20. 20 is 4 times 5, which is plus or minus 2 the square root of 5. So it'll be more than 4. So somewhere up there, that's where the focal point is. It's going to be 0, 2 the square root of 5. And the other one is down here. 0, negative 2 the square root of 5. Again, sometimes we play games with you. We don't give you everything. We don't make it look like this. You got to make it look like this, or you got to find A and B before you can graph it. So let's take all of these examples. So here's one. Nine, I'll make it fun here, y squared over 25 minus x squared equals 1. That doesn't look like anything we did. The positive is y, so we know it's along the y-axis. So I need to match this form. So how can I take that 9y squared over 25 and rewrite that? What can we do? Any suggestion?
Multiply by 25.
I want to make it look like this. So how can I write that y squared over what?
5 squared.
How about 25 over 9? When you divide by 25 over 9, is that the same as multiplying by 9 over 25? And I can make that what? X squared over what? 1. This is my A. A squared equals 25 over 9. What is A equal to? 5 over 3? Like 1.7 roughly? And B squared equals to what? 1. What's B equal to? Plus or minus 1. Just to make it big, I'm going to make each one of them. Here we go. This is 1. This is 2. I'm making the scale really big. 1, 3, 4, 5, 6, 5. This is 1. This is 2. Negative 1. Negative 2. Negative 1. Try and make it big so you get to see it. Negative 2. A is 5 over 3. 1 and 2/3. So 1 somewhere here. That's your vertex. V equal at 0, comma 5 over 3. And the other one right here, 0, comma negative 5 over 3. B at 1, that's here and here. So let's make the box here.
But you put it on the wrong spot.
Oh yeah, down here. The other one is good, I think. 1, 2, 3, 4, 5. Yep, the other one is good, just this one is the wrong one. Good eyes. I could have just fudged it, relabeled that one. I gotta make my box here. I gotta make my box here. I gotta make this one. Gotta make this one. Sounds like gotta make the donuts. Here we go. And now run my axes here. My asymptotes. And again, I know it's going to pass through this point, and it's going to level with that, so it's going to look something like this. Now you can't read the numbers, but that's what the graph is going to look like. What is my focal point? Well, I need to find what C is. C squared equals A squared plus B squared. 25 over 9 plus the 1. The 1 is what? Isn't that 9 over 9? 34 over 9. C equals the square root of 34 divided by 3. Square root of 9 is 3. Whatever that number is, somewhere here, that's where your focal point is going to be. 0, comma, the square root of 34 over 3. And somewhere, I don't know where exactly, 0, comma, negative 34 over 9. What's that? A little more than 2. No, more than 3, actually. So that's where the focal point is going to be, up and down. Again, the conjugate axis, remember, conjugate axis, that's twice A. Transverse axis, twice B. So in this example, what's twice A? 10 over 3. What's twice B in this example? 2. B is 1. So the transverse axis, the distance from here to there, conjugate axis from vertex to vertex, right here. That's 10 over 3. I'll take one example where we're going to give you that information, have you work it backward, and see if we can get that. What's the slope, by the way? What's the equation for this line if you were to find it? What's the equation for this line? Anyone? Y equals what? Isn't it mx plus b?
Yes.
And what's the slope? The rise over the run. What's your rise?
1.
Nope, the rise is that height. 5 over 3. And what's the run? 1. So this will be 5 over 3 x. The y-intercept is 0, right? And what's the equation for this if you need to find it? Better be negative 5 over 3 x. So if you know that equation too, you can figure out what a and b are, because you know what the slope now. Maybe I'll do the example that way, the next one. That's an idea. Let's try that. Make it the last one on this section. Asymptote is y equals negative 4x. Vertex at 0, comma 4. I can tell you what the graph looks like, then I'll come up with the equation. Where's my vertex? 0, comma 4. 1, 2, 3, 4. That's the vertex. That tells me it's up and down immediately. So I know it's y squared over a squared minus what? X squared over b squared is equal to 1. Do I know what a is? A equals what? 4. That's the distance to the vertex. That's A. That's the other vertex. The other one, they tell me what the slope is, y equals negative 4x. So we know it goes through that point, negative 4, which means what? That's 4 over 1. Go 1 to the right and 4 down. So it's going to go through that point, right? 1 to the right, 4 down, or 1 to the left and 4 up. So that line actually goes through that point. That means that's a corner. There has to be one here, has to be one there. That's your other corner. So you know what B is. B is what? B equals the distance from here to that. That's a 1. Plus or minus, which means B squared equals what? 1. A squared equals 16. If you finish your box, plus you know the slope. The slope is 4. We know it's B over A. Is it B over A? I mean, in this case, A over B for this example, right? The rise is what? The rise is A here, right? Because you're going up, this is A. So in this example, it's A over B. It's up and down. If it was left to right, it would be backward, B over A. We know what A is 4. B will have P1. A is the distance to the vertex. That's A. So the height is A. This is B. So here's my equation. Y squared over what? 16 minus x squared over 1 is equal to 1. If I want to graph it, really tight like that. Can we find what the focal point? C squared equals A squared plus B squared. C squared equals 17. C equals plus or minus the square root of 17, just a hair over 4. So my focal point is right there, right below the 4 and above the 4. So that focal point is 0, comma, the square root of 17. And this focal point here, 0, comma, negative the square root of 17.